Chapter 3, Lesson 8, Solving Systems of Equations Algebraically. We've already learned how to solve systems graphically, but today you'll be able to solve systems of equations algebraically. That means without a graph and just by rearranging some things. So here are the steps to follow. Set the equations equal to each other. Solve for x. Use what you got for x and plug it into either equation to find your y. And then you write your answer as a point, x comma y. So let's go through a couple of these together. Now if you notice, they're both y equals. So if y equals 2x plus 3 and y also equals 6x plus 5, then it's only logical that they equal each other. So 2x minus 3 equals 6x plus 5 because they're both equal to y and y is the same thing. So let's solve this equation. Subtract 2x from both sides. You get negative 3 equals 4x plus 5. Subtract 5 from both sides. You get negative 8 equals 4x. Divide by 4. You get negative 2 equals x. So that's the first part. Then what you do is you take your x value and plug it into either equation. It does not matter which equation you use. I'll just use the first one. Y equals 2x minus 3. Rewrite the equation you are using. Now take your x value of negative 2 and plug it in for x. So y equals 2 times negative 2 is negative 4 minus 3. And negative 4 minus 3 is negative 7. So your answer, if you put it in xy form, which you should, your x is negative 2, your y is negative 7, and that's it. So if you were to graph these lines, they would intersect at the point negative 2, negative 7. Let's do another one. Letter B. Y equals x plus 4 and y equals 2. So it only makes sense, since they're both equal to y, they must be equal to each other. So we write x plus 4 equals 2. Solve the equation. Subtract 4 from both sides. We get x equals negative 2. Pick an equation. Let's choose the first one. Y equals x plus 4. And let's plug in negative 2 where x is. Y equals negative 2 plus 4. Y equals, well, negative 2 plus 4 is 2. And write your solution as an ordered pair, x coming first, negative 2, comma positive 2, and that's the solution. Sometimes you won't have both equations equal to y, but we also know how to change it so that they do equal y. So the first equation in letter A is fine. Let's look at the second equation. 8x plus 4y equals 12. So the only thing we have to follow now is to get y by itself first. So I'll subtract 8x from both sides. And I get 4y equals 12 minus 8x. Well, I still have to divide by 4, and the trick here is you divide everything by 4, so all three terms. Y equals 3 minus 2x. So now I have a second equation, and now they're both equal to y. So I can now say that this equals that. So 3x plus 8 equals 3 minus 2x. And let's solve this equation. Let's add 2x to both sides. We get 5x plus 8 equals 3. Subtract 8. 5x equals negative 5. Divide by 5. X equals negative 1. Now that we have x, let's plug it into an equation, and I'll choose the first one. Again, doesn't matter which one you choose. Y equals 3x plus 8. We are plugging in negative 1 for x. Y equals 3 times negative 1 plus 8. Y equals negative 3 plus 8. Y equals 5. So as an ordered pair, x coming first, we have negative 1, comma, 5. Again, let's take our second equation and set it equal to y, or solve for y. We're going to subtract 3x from both sides. 4y equals 26 minus 3x. Divide everything by 4. We get y equals, well, 26 divided by 4 would be, looks like 6.5, so 6.5. Minus, and leave your slope as a fraction. The number before x, leave it as a fraction. Now we have our equation set equal to y. We're going to take this part and put them equal to each other. 2x plus 1 equals 6.5 minus 3/4 x. Add 3/4 x to both sides. 2 plus 3/4 is 2.75x plus 1 equals 6.5 minus 1. 2.75x equals 5.5. Divide by 2.75. It's exactly 2. So that's our x value. Now we take our x value and plug it into an equation. I'll choose the first one. Y equals 2x plus 1. We're going to plug 2 in for x, so y equals 2 times 2 plus 1. Y equals 4 plus 1, or y equals 5. We have x, we have y. Our ordered pair is 2, 5. Letter C. This one's a little bit tricky here. A total of 75 cookies and cakes were donated for a bake sale to raise money for the football team. There were 4 times as many cookies donated as cakes. So we have a total of 75 and 4 times as many cookies as cake. Let x equal cakes, let y equal cookies. Write and solve a system of equations and interpret the solution. Okay. Well, first of all, we know that there was a total of 75 cookies and cakes. So if we take x plus y, our cookies plus our cakes, that would equal 75. That's our first equation. The second equation is that there are 4 times as many cookies as cakes. So 4 times the cookies equals the cakes. Again, 4 times the cakes equals the cookies. Okay? Again, x and y are defined as the cookies and the cakes. Now we have our 2 equations. Our first step is to get this one equal to y. So x plus y equals 75 minus x from both sides. we get y equals 75 minus x. Now we take this one and put them equal to each other. 4x equals 75 minus x. Solve the equation. Add x to both sides. Remember, that's really 1x. So 5x equals 75. Divide by 5. X equals, well, 5 into 75 once, 5 times, so 15. Now that we have an x value, plug it into either equation. I'll choose the second one this time. It doesn't matter, but let's do 4x equals y. Let's plug it into that one. 4x equals y, plug in the 15. 4 times 15 equals y, or 60 equals y. So your ordered pair is 15, 60. The next part is to interpret the solution. So remember, x is cakes and y is cookies. You want to know what was sold at a bake sale. So again, this is cakes and cookies. So to interpret the solution, what we would say is, at the bake sale, 15 cakes and 60 cookies were sold. That's all you would have to say.